Thank you, Travis, for that introduction, and thank you to the conference organizers for inviting me to speak. This has been a terrific conference so far. I think that's been very informative and interesting, and hopefully my presentation will carry on that fine tradition. As Travis said, I'm the manager of LNG and CNG development in Noble's Denver office, and I show you this map not so much to talk about Noble's global portfolio, but for those of you who aren't as familiar with where Denver is, we're the northern and westernmost star here in the, oops, there we go. But we're that star there in the western U.S. We're 1,000 miles from water, so I've really enjoyed staying in a hotel right on the Mediterranean. It's been really lovely. In addition, what I'm here today is to share some of the experiences and learnings we've had over the last 3 or 4 years that we've been working on compressed natural gas in the DJ Basin in Colorado. I'll talk a little bit about our pilot project on CNG pickup trucks. I'll also talk about how we've been working in an innovative public-private partnership with Weld County to develop CNG fueling infrastructure in the county. I'll also touch a little bit on our CNG school bus project, where we're working with a lot of local school districts, and wrap up with a few summary comments and observations. So we started with our CNG for pickup trucks pilot in late 2009. We converted 10 2008 model year Ford F-250s, working with a local aftermarket CNG conversion company there in Denver. We were limited at that point by the infrastructure. There was only one CNG station in Weld County. It was on the very southern edge of our field. And so our lease operators who go out and visit the wells every day are the people we're using these trucks for, and very few went down to that area. But we were able to find 10 who either lived in that area or whose daily routes took them by that station, and we converted their trucks. These conversions on the trucks are to biofuel, so that they run on CNG or gasoline. They switch seamlessly back and forth, but they run on one or the other at any given point in time. The way we convert the trucks is we install the CNG tank right behind the cab, put a cover over it so it looks a little bit like a toolbox sitting behind the cab of the truck. Depending on the size of the cylinder, it's 16 to 18 inches in diameter, or 40 to 45 centimeters in diameter, and stretches across the width of the pickup truck bed. The other part then is just running lines from that cylinder, which we in the U.S. operate at 3,600 pounds or 248 bar, as Mr. Haberly described earlier, and running it into the engine. We basically mount a second set of fuel injectors on the engine so that you still have your electronic fuel injectors for the gasoline, and you add on a set of fuel injectors for the compressed natural gas. Really, the pilot went very well. We really had two issues. One was driver education, getting them familiar with CNG. It's amazing when you fill up with CNG. It's just like filling up with gasoline. You pick up the hose off the dispenser, you put it, attach it to the vehicle, you turn on the dispenser, you turn on the nozzle, it fills up, you turn it off, take it off, put it back. But the fact that this is a different kind of hookup rather than a nozzle throws everyone for a loop. Once you kind of walk them through that it's really the same process, the only difference is how you hook it up to the vehicle, they get more comfortable with it. And I have to admit, the first time I did it, there's kind of this unknown to it. So it does take some education. It's different. It's a little different from business as usual, but it's something that you can teach people and they get over. The only technical issue we had was a couple of catalytic converter issues on two of the trucks. This introduced us to one of the downsides of working with an aftermarket installer. The aftermarket installer provides a warranty on his system. The OEM, the original equipment manufacturer, Ford in this case, provides an equipment warranty on their system. However, when you have an issue with the catalytic converter, which both of their systems touch, the question becomes, okay, who caused the catalytic converter issue and who pays for the fix on that? So that's one of the issues that we experienced during the pilot. But overall, it was a very good experience and very positive. So we ran that for about a year, and after that decided we wanted to continue to convert trucks, so we converted 10 additional trucks in late 2011. After we got to that point, though, we were kind of saturated in terms of what we could do because of the location of the station. We were kind of stymied at that point, and I'll tell you a little bit about the Weld County Smart Energy Project, where we worked on additional fueling infrastructure. The other part we were concerned about after our catalytic converter issue was we really wanted OEM product for compressed natural gas. And so we really had two good things happen in 2012. First, all three of the big American manufacturers announced some type of OEM type product in the 3/4 ton pickup truck class. That had been driven a lot by the fact that America's Natural Gas Alliance, ANGA, a consortium of E&P companies like Noble, had been pushing the manufacturers because a lot of us operate hundreds and across the industry thousands of trucks, and the industry as a whole wanted to really move to compressed natural gas. And so the OEMs responded and started offering product. That from our experience as a consumer, we can now go to our Ford dealership, we can order a biofuel pickup truck, and it gets delivered to us. And to us, it looks just like a Ford product. In this particular case, Westport is the qualified vehicle manufacturer, or QVM, who works with Ford. And the way it actually works behind the scenes is the truck comes down the assembly line in Louisville, Kentucky. They pull it off, they take it across the street to Westport, they put on the CNG kit, they put it back on the Ford assembly line, and it comes out the back end. Then for us, from a consumer perspective, if we have a warranty issue, we take it back to the Ford dealership and they deal with it. So from our perspective, it's just like an OEM product, even though in a very narrow sense, it isn't. So OEM products became available. The second big piece then was the fueling infrastructure. And I'll tell you a little bit about the Weld County Smart Energy Project, but through that we got fueling infrastructure put in. So in mid-2012, our management made the commitment that all pickup trucks that we purchase in the DJ Basin going forward in that 3/4 ton class will be biofuel. So we slowly turn over our fleet over about a 5-year period, and we expect that by the end of 5 years, by 2017 or 2018, we'll be running 300 plus trucks in the DJ Basin as of the end on CNG. As of the end of 2013, we were at 85. We also had another 15 trucks and a couple of other field offices, one in Appalachia, that were running CNG, so we had about 100 company-wide. In terms of the economics of that program, here's what it looks like. Our typical gas mileage of the F-250 is about 12 miles to the gallon. We drive them about 30,000 miles a year. Really, it's 10 to 12 miles a gallon, but for this illustration, I'm assuming higher mileage and therefore less fuel consumption. If you look at this middle column over here, the 2013 Ford F-250 with the Westport package cost just under $40,000. We get a tax credit that's worth 12.5% of the retail purchase price, so just under $5,000. The incremental cost of the CNG system in this case is just under $9,300. So our net after-tax cost of our system is $4,300. With an annual fuel usage, 30,000 miles divided by 12 of about 2,500 gallons. If we use 80% or CNG 80% of the time at $1.25 per gallon cost savings, we wind up with a savings of about $2,500 a year, and we pay off the investment in less than 2 years. Even in the absence of the tax credit, we would pay off the investment in 3 to 4 years. Noble's philosophy on our trucks is we buy the trucks, we run them for 150,000 miles, and then we replace them. So the exact timing will vary depending based on the driver, but that's how we work it. So even in the case where we had no tax credit, we would pay it off in 3 or 4 years and then enjoy a net savings on fuel for that last year and a half or so. The Weld County Smart Energy Project then was something that we worked with the county on to address the lack of fueling infrastructure in Weld County. I showed you earlier the map of the U.S. and where the DJ Basin is. This is a map of Colorado here. So you can see the whole state here. This, I'm not sure what color to call that, light reddish portion is Weld County. Weld County is about 4,000 square miles. It has about 250,000 people. The major highway through the county is U.S. Highway 85, and Noble operates about 8,000 wells here in the DJ Basin, most of which are in Weld County. Not all of which, but most of which are in Weld County. Looking at it a little more closely, you see the major transportation corridors in Weld County are I-25 here along the very western edge, Highway 85, which runs through the heart of the county, and really the heart of the population is here in Greeley and mostly south, although there's still a little bit north. As you go further east, it is much more sparsely populated. The major east-west transportation corridors are U.S. Highway 34 here, and Interstate 76 here running across the southern edge of the county. So what we did was we worked with Weld County. They got some federal dollars for improving air quality. One of the great benefits of CNG vehicles is a reduction in emissions, an average of 25 to 30% reduction in CO2 emissions versus a similar gasoline vehicle on a well-to-wheels basis. NOx and VOC are a little harder to nail down what those exact emission reductions are, but there's a lot of data out there that suggests the emission reductions are on the order of 30 to 70% for NOx and 80 to 90% for volatile organic compounds or VOCs. NOx and VOCs are both precursors to ozone, and the Denver area is non-attainment in the United States for ozone, which means we have too much ozone and we exceed the federal standards for ozone. So doing things to reduce pollution from vehicles is a big deal for Weld County and a big deal for Noble Energy. So they got the federal grants. Noble Energy and 2 other industry partners contributed towards those grants, provided some private matching funds that were needed to get the grants. And so together between the federal dollars and the dollars that we and others contributed, we wound up with about $2 million in grant funding. We then went out and bid out 4 stations, providing roughly $500,000 for each station. Each station cost about $650,000 to $750,000, so the winning bidder still had to bring $100,000 or $200,000 to the table to build the station. So they did have some skin in the game, but it also greatly lessened the cost so that they could go ahead and do it and move forward with it. So in 2012, we got 4 privately owned stations opened. You can see here one kind of in Greeley, on the north side of Greeley. It's selling here at $2.24 per gasoline gallon equivalent in terms of price. One here on the 34 corridor going east-west out of Kersey. One down here on kind of the western edge of the county in Firestone, and one down in the southern edge of the county in Fort Lupton. If I go back a map just to show those a little bit. So we have Greeley, we have Kersey, we had Firestone down over here, we had Fort Lupton in here. As part of our school bus project that I'll talk about in a minute, we are also constructing a station in Gilchrist, which is about right here. And so at the conclusion of our project, we will have 4 stations on this Highway 85 corridor, from the old station that's in Brighton, the station that just got constructed in Fort Lupton and Greeley, and then our station in Gilchrist. And so we'll have 4 stations up this Highway 85 corridor through the heart of Weld County. So moving on to the school bus project, how did Noble get into working on the school bus project? This really brought together a lot of diverse interest in the state. Colorado's been a leader in the area around natural gas vehicles, and the Colorado government, the Colorado governor has been very supportive. One of the things that's happened is this multi-state memorandum of understanding for CNG fleets, where the governor of Colorado signed led the signing of a memorandum of understanding with a lot of other states to preferentially purchase compressed natural gas vehicles for their state fleets. Last year, Colorado, as a result of that, purchased around 80 vehicles, and when you added up all the states, I believe it was 1,500 to 2,000 vehicles. So it's sending a signal to the automotive manufacturers that there is demand for CNG vehicles, and if you build product, we will buy it. Additionally, Colorado, through the Governor's Energy Office, has now announced a $30 million project to further put in infrastructure throughout the state, as well as to incentivize medium-duty and heavy-duty trucks to convert, or really the purchase of new medium-duty and heavy-duty trucks running on CNG. There's also Weld County has been very focused, obviously, on the use of CNG. Noble has done a lot around using natural gas as a fuel. That's why I have my position. We're doing a lot of things to use natural gas for our drilling rigs, for our pressure pumping, for our pickup trucks, and for our supply chain as well. And the northern region has traditionally focused its community outreach efforts on things around children. And so when we kind of looked at the different things that are going on out there, we thought the CNG school bus project brought all 4 of those items together in a very nice way. So we announced the CNG school bus project in May of 2012. It's a $5 million commitment over 5 years. We're reaching the end of phase 1 right now. We've delivered 5 buses to the Valley RE1 school district, which is that area kind of south of Greeley, Platteville and Gilchrist, and 2 to the Greeley-Evans RE6 district. We are also building a bus storage and maintenance facility for the Valley RE1 school district, and we've awarded the CNG station to Ward Energy, and that station is under construction and will be operational in June of 2014. We've contributed about $1.4 million to date between some co-funding from some different government grants as well as a couple of $100,000 from one of the school districts. We've gotten matching funds of about $1.3 million. So it's been a $2.7 million project in terms of what we've spent to date. Phase 2 is being planned. We're going to extend it to at least 3 other school districts. The ultimate goal of the project is to do something with each of the 12 school districts in Weld County, and so we're working towards that. One of the things that's important for us on this is that this project is sustainable. And so by working with the Weld County Smart Energy Project around infrastructure, by putting in some infrastructure as part of this project, we're hoping to create a long-term sustainable infrastructure in Weld County that the buses will be able to continue to use. Then the savings that the school districts realize from the buses can be used to purchase buses in the future. Just a couple more things about why we're doing the school project. The schools in Colorado have suffered a huge cut in funding since 2006-2007 as part of the recession. Tax revenues go down. In Colorado, the school budget makes up about 40% of the state's general budget, so when the state's revenues go down, there aren't a lot of places to cut without impacting the schools. So their numbers, their funding dollars have fallen a lot. Even today, with a little bit of the rebound, the schools still have about a $1 billion shortfall in funding from where they would be if we had normal tax revenues. So schools, like families, if they don't have money, they cut back where they can. One of the things they do is delay purchasing new buses. And so some of the bus fleets we've gotten are quite old. You see the Greeley bus fleet is about 15 years old. That's the average age of the bus fleet. Some are as old as 25 years old. These are also both districts where the populace is not terribly affluent. You see that 60 to 70% of the students in those 2 school districts qualify for free or reduced lunch prices because of their family's income. So we're trying to reach out and help the community in areas that they need it. So a couple of pictures from our school bus delivery ceremony. You see here the science and technology class at Northridge High School in Greeley loaded on a bus. A number of dignitaries in front of the bus. On the far right-hand side is my boss, VP of the DJ Basin, Dan Kelly. I'm way over here on the left side. And we have here a number of school superintendents, school board members, local county commissioners, and other dignitaries. Some of the messaging we put on the buses, we came up with a couple of different things that we hoped were pretty catchy. Underneath, I'm actually green, powered by clean natural gas and noble energy, and also a smarter way to get to school. Which we thought was kind of a little play on the Weld County Smart Energy Project, as well as hoping people help people recognize why it's good to use natural gas as a motor fuel. So to wrap up, we think some of the experiences we've had in Colorado will hopefully be helpful here in Israel and will help inform the conversation going on in Israel. As I looked at it, our experience with 3/4-ton pickup trucks, I think, may be helpful to some of the light-duty opportunities here in Israel. In particular, Israel has 20,000 taxis that run about 80,000 kilometers a year, which is about 50,000 miles a year. You look at kind of fuel usage, and that's probably that same 3,000 gallons a year type number with all the idling that taxis do that we saw on our pickup trucks. And you consider the cost of a conversion on a taxi is probably about the same as our pickup truck, maybe a little less because it's probably a smaller tank since you don't have quite as much space, and the tank is a significant cost. And so those economics that I showed for the pickup trucks are probably pretty close for taxis here in Israel. One of the big questions with CNG is always what comes first, the chicken or the egg, the vehicles or the infrastructure. The way we addressed that in Colorado was with our public-private partnership with Weld County to help build out the infrastructure. Noble and other companies in the area had all expressed interest in committing their fleets, but we didn't have infrastructure. And so we were able to provide the infrastructure operated by privately owned third parties, and that enabled us then to continue with our fleet conversion plans. So we think government incentives, partnerships, commitments are a key piece to getting the market kick-started and are helpful in building those initial fleets and infrastructure. Our school bus project, we think, helped educate the community about what you can do with CNG and what are the advantages of running CNG. And also we hope, over time helps build a level of comfort. More and more people hear about CNG, they start asking questions, they start becoming educated, they start becoming more comfortable with it all. Finally, just a couple of other observations about the market. In the U.S., 50% of the new refuse trucks are CNG. and 20 to 30% is the number I had. Mr. Haberly mentioned 35% of the transit buses are CNG. Those are the two market segments where natural gas has really achieved mainstream status and has achieved huge market penetrations. And in both of those instances, we've grown the market to volumes where the incremental price is only 10 to 15% greater than the comparable diesel cost, and they both have gotten payouts of less than 2 years. In the other markets where our market segment, our market share is less, we haven't reached those kind of metrics. So I think in terms of widespread adoption of natural gas, it's getting to that area where you have low incremental cost, you have a quick payback of a couple of years. A lot of that is getting through volume. And your question is, how do you get there? How do you incentivize the market to get there? What is the right policy mix of government incentives to do that? And that's what I think, a lot of the challenges that face Israel. We look forward to trying to be a part of the conversation and bringing our experience to bear and trying to be helpful in that process. That concludes my remarks, Travis. I'm happy to answer questions, or if we can do that later, I'll turn it back over to you.